So today we're going to talk about function operations, which is lesson 1-2. So we're going to split this set of notes into two different videos. So these notes cover lesson 1, 2, and 1, 3. But today we're going to specifically look at just function operations. Function operations just means that you're going to take the function notation we talked about before, and we're going to add two functions, subtract two functions, multiply two functions, or divide two functions. And these are just two different ways of showing the same notations. This means to add two functions, that means to add two functions. This means to subtract two functions, and that means to subtract two functions, and so forth. So the steps are going to be as follows. So look at example 7. We've got f of x is x squared plus 2, and g of x is x minus 6. So we're going to add the two functions together. So typically you're going to see me doing two big parentheses. So two big parentheses and then a plus and then another set of parentheses. So they've already filled in part of it for you because they've already put in the f function in here, which is the x plus 2, went right in here. So then we're going to add the g function right here, which is x minus 6. So let's put the x minus 6 in. And then you're just going to collect like terms. There is nothing in front of these parentheses or these parentheses that are going to change anything inside them. So you can just drop the parentheses and collect like terms. So we've got 1x squared. There's no like term here to that, so that's where this x squared comes from. And then we've got the next highest degree term is this x. It has no other like term to combine with it, so that's where this x comes from. And then the 2 and the minus 6 combine to give you a minus 4. So this is the sum of the two functions. Then let's look at problem 1. So in problem 1, our f function is 2x squared plus 8, and our g function is x minus 3. And they want us to add the two functions and then subtract the two functions. So we're going to start with adding the two functions. So if I add them, I've got two big parentheses plus, I'm going to put the f function first because it came first, so 2x squared plus 8, and then my g function is just x minus 3. So if I combine like terms, and I'm going to have to select here which one of these is the correct answer. So I've got a 2x squared, so that's got nothing else to combine with, so I know that's going to be my final answer. So it's got to be this one or this one. I can eliminate those two as choices. So that's what I'm going to do. Eliminate those two. Then my next highest degree term is the x. So I know I'll have 2x squared plus x because there's no other like term, so that doesn't eliminate anything here. They both have that. And then 8 and a negative 3 gives us a 5, so it has to be this answer here. So this is the correct sum of our two functions. Then we're going to subtract the two functions, so I'm going to do that over here off to the side. So I'm going to have big parentheses minus big parentheses. So again, the f function comes first, so it has to be in the first set of parentheses. So I've got 2x squared plus 8. And then my g function comes next, and that's x minus 3. So the only thing you have to be careful of with subtraction is that you've got to take this negative and distribute it all the way inside the parentheses. It's like having a negative 1 in front that you have to multiply through. So there's nothing in front of the first set of parentheses, so I can drop those. I get 2x squared plus 8. A negative 1 times x is negative x. And a negative 1 times negative 3 is a positive 3. So to figure out which one of these answers is the correct one, I have a 2x squared. It doesn't combine with anything, so it's got to be, again, one of the first two, so I can cancel those two out. So let's cross those out. So now I have a 50-50 shot. Then the next highest degree term is this minus x, and again, they both have a minus x. So then 8 and a positive 3 is positive 11, so it has to be the very first one. Then they want to know what is the domain of the f function. So if you look at the f function, the domain, remember, are x values. And so what kind of numbers can I put in for x? Can I put negative numbers in? Sure. Positive numbers? Sure. 0? Absolutely. Fractions, decimals, I can put any number I want to in here and I will get a real solution or a real answer. So my domain is all real numbers, but I want you to start to think of it in terms of the very smallest number on the x-axis that you can think of is actually negative infinity. So I can go from negative infinity all the way to positive infinity. So this is just a way of writing the domain in a new type of notation. It looks like an ordered pair, but it's not. You're going to put your least value to your highest value that your x can be. So x can go anywhere from negative infinity to positive infinity. So let's write the domain of g using the same thought. Is there any number that we wouldn't be able to put in for x and then subtract 3 from? No. We can put any number we want to in for here and get a value. So the domain for g is, again, negative infinity to positive infinity. Well, that's a lovely positive infinity. There you go. That still looks pretty bad, but we'll go with it. Then they want to know what the domain of both the sum of the functions and the difference of the functions. So as you look at your answers here and here, again, ask yourself, can I put any number I want to in for x? Of course. Of course. So since I have no restrictions on my domain, it's going to look like the previous functions. It doesn't always happen that way, but in this case it is. So again, they're both negative infinity to positive infinity. Okay, problem 2. Now we're going to multiply and divide our functions. So the first one, when we multiply, I'm going to take 2 big parentheses and I'm going to put the f function in blue and the g function in red. So we have 2 different functions, different than what the previous problem 1 had. So we're going to start off with 3x squared minus 11x and then minus 4. And then the g is 3x plus 1. So then we're just going to distribute. We're going to have 3x squared times 3x. So remember, you're going to multiply coefficient to coefficient, like base to like base. So I end up with 3 times 3 is 9. X squared times x, add the exponents, you get x cubed. Then 3x squared times 1, you get 3x squared, so plus 3x squared. Then we are going to multiply the negative 11x. So negative 11x times 3x gives us a negative 33x squared. So I'm going to put that below here, negative 33x squared. And then negative 11x times 1 is negative 11x. So negative 11x. And then finally we have to multiply the 4 through. So I'm going to multiply 4 times 3x is a negative 12x. I'm going to put that up here, negative 12x. And then negative 4 times positive 1 is a negative 4. So then we're going to collect like terms. I've already lined up terms that are alike to make it easier. And again, we have some choices down here. So our highest degree term is going to be this 9x cubed. And they haven't even given us the proper full. Okay, so we're going to go ahead and circle the one that we can see that's alike. In other words, this is the one we started with. Technically, that's not your answer because you have to fully simplify your answer. So we're going to finish that up here so that you know what it should look like. So our final answer should be 9x cubed, and then a positive 3 and a negative 33 is negative 30x squared. Negative 12 and negative 11 is negative 23x, and then minus 4. So that is your true answer to that product. Then for number 14, we're going to take f and divide it by g. So we're going to take f on top. So f comes first. So f should go on top. That says 3x squared minus 11x minus 4. So this is the only one that shows a fraction with f on top. This would be the product. That's not what we want. And then our g is on the bottom. So here's our g, here's our g. So that's the one that we're looking for. You want to make sure when you have division that you factor the numerator and factor the denominator. So we're going to see if we can factor this numerator. We're going to multiply 3 times 4, which is negative 12. Are there factors of 12 that subtract to give you 11? Yes. So we're going to go ahead and factor that. So I think I'm going to do my factoring let's see, maybe I can move my notes. Yep, so I'm going to move them up a little bit. So let's do our factoring down here. So I'm going to take 3x squared, where'd it get? 3x squared minus 11x minus 4. So we've talked about this factoring method in class. We're going to take this 3 and multiply it to the 4 and create a new trinomial, x squared minus 11x minus 12. And so we're going to read this backwards exactly as we see it. What factors of 12, because it's negative, we're going to subtract. So 12 is negative, we're going to subtract, and we're looking for the middle term of 11. Don't worry that 11 is negative right now. So your factors of 12 are 1 and 12. Those subtract to give me 11, and I got it immediately on the first try. So my sign for my middle term 11 is negative. 100% of the time, the bigger of the two terms carries the same sign, so the 12 also has to be negative. The 1 is going to have to be positive in order to combine with that negative 12 to make a negative 11. So then we're ready to throw these into the parentheses. The x squared becomes x and x, and then we're going to have a plus 1 and our minus 12. But because we originally multiplied by 3, we're going to have to divide by 3 before we find the final factoring. Now remember, if 3 doesn't divide in there evenly, you have to pop it up in front. So we end up with 3x plus 1 times x minus 4, because 12 divided by 3 is 4. So I'm going to go back up here and write my factored form, 3x plus 1 times x minus 4. So that's our numerator, our f function, and it's all over 3x plus 1. That cannot be factored. So now I can actually cancel the 3x plus 1 with the 3x plus 1. So my final simplified form is x plus 4. Now, restrictions. Anytime you have a variable in the denominator, you have to do what are called restrictions. So this denominator cannot have a value of 0. No denominator in a fraction can have a value of 0. You can't take something and divide it into no parts. So we have to determine what value for x would cause this denominator to be 0. And it's not 0, because if x were 0, we'd have 0 times 3 is 0, plus 1, the value would be 1. So to figure out your restrictions, we're going to do it down here. I'm going to take whatever my denominator is, even though it canceled out, and it's 3x plus 1, that's my denominator, and I'm going to set it not equal to 0. And then we're going to solve for x. So subtract 1, I get 3x does not equal negative 1. And then we're going to divide by 3. And so my restrictions, which have to be added onto my answer, would be x cannot equal negative 1 over 3. So that's part of your answer. So we already simplified the product and quotient, so we already did these two. And then for what values of x does g of x equal 0? And we found that here. So we're good to go on to the next problem. Here we go. So now 18 wants the domain of the product of f times g, and 19 wants the domain of the quotient. So remember that our product had no denominator. So because it had no denominator, we can have anything we want. We can put anything we want to in for x. So your domain is still going to remain negative infinity to positive infinity. But remember that we had a restriction with the quotient, with that denominator that was 0. If I were to put that on a number line, it looks like this. Here's negative 1/3, here's 1, and I don't know, here's negative 1. If we were to graph this on a number line, our x can be anything we want it to be for that quotient, but it can't be -3. So we put an open circle at -3 and an arrow to the right and an arrow, those are arrows, weird but true, and it would look like that. So remember, the very smallest number on the x-axis is negative infinity and the very largest number is positive infinity. So we actually have two parts to this. We're going to go from negative infinity up until negative 1/3, jump over this and go from negative 1/3 and to positive infinity, but we're never going to include that. So our notation will look like this: negative infinity to negative 1/3. We're going to use parentheses because it's an open circle. If it were a closed circle, we would put brackets. We're going to use this U for union, and then we still have, whatever we ended with, we have to start with again because we don't want it included, but we want to come close to it and go to positive infinity. Okay. And that is the end of today's lesson, and we'll do the composition of functions for the next video.